Hello everyone, and welcome back to another video. My name is Jamil, and today I'm here to help you solve another lead code. So on today's menu, we have lead code number 1534, count the good triplets. It is another company's question. It looks like it is heavily disliked. Not really sure the reason why, but I mean, the solution probably will point towards that. It isn't really like a good solution. It's kind of ugly, but it is a question that we should probably try and knock out of the way for those interested in trying to understand, or who might come across it in an interview. So, without further ado, let's try and understand what the problem is asking of us. So, we are given an array of integers denoted by the variable array, okay, and 3 integers denoted by variables a, b, and c. You need to find the number of good triplets and the number of good triplets. So what is a good triplet? A good triplet is when array I, array j, and array k, so 3 different indices, like 3 different variables in the array, is good if the following conditions are true. All right. So 0 is less than the index I is less than or equal to than the index I, which is less than the index j, which is less than the index k, which is less than the array.length. So what the hell does that mean, right? Like, what I, j, and k are in this case are numbers. They are They represent index values, right? So I could be 0, j can be 1, and k can be 2, and this satisfies this condition. But I cannot be 1, j cannot be 0, and k cannot be 2, because then I is not less than j, and therefore it's not a good triplet. Okay? So we must maintain like the order of the array, and basically what we are comparing is our current position with 2 future positions. Okay, and another condition for each of these numbers that we see is that a triplet is good if the absolute value of the difference, which means when we subtract the 2 numbers, and we don't care about the direction, so we just care about the difference, is less than or equal to the number passed in the variable a. J and k less than the number passed in variable b, and same thing with variable c. Okay? Where the 2 straight lines and an x in between denotes the absolute value of x. So again, as I mentioned, do not care about the direction, but just the difference. And return the number of good triplets. Okay, so there is going to be a counter. We just need to run a counter on the program. All right? So in example number 1, we have an input denoted by, array, and it's 301197. We cannot manipulate this array. We need to keep it in its original order. And a is equal to 7, b is equal to 2, and c is equal to 3. And we're expecting an output of 4. Okay? And the reason is because there are 4 good triplets. So let's take a look here. We have 3, 0, and 1. Okay? That is the first 3 elements in the array. 3 is denoted by array of 0, which is less than the, and 0 is denoted by array of 1. So I is 0 in this case, and j is 1. Okay? And though the difference is 3, since 3 minus 0 is 3, and it's less than the number 7. So this condition right here is true. Okay? So we have determined that we're still on an array of 1, j did not change, but k is 2. Okay? So if k is 2, sorry about that. That means that we are taking a look at the number 1. So 0 minus 1, which is the difference is 1, and it's less than the number 2. So this condition is true. And then finally, array of 0 minus array of 2, which is 3 minus 1. Excuse me, I'm just working myself over a cold. 3 minus 1. So the difference is 2, and that is less than c, which happens to be the number 3. So that makes it a good triplet. Okay? And then you continue doing this for the rest of the array. So you have to iterate. You have to check your current array, or your current index, and then you have to check 2 future indices. So we're going to be requiring 3 loops for this. It's going to get a little bit messy, and on our 3rd loop, we're going to be running a check. Okay? So our constraints, the length of the array will have to have at least 3 numbers so that we can at least, satisfy this check. We need to check 3 different numbers. Array I can be anywhere individually, like each number can be either between 0 and 1,000. And a, b, and c can also be between 0 and 1,000. Okay? So perfect. Let's take a look here. we're going to need to figure out what is being passed. Okay, so we are passed 4 arguments, right? And the first argument will be an array of numbers. We should take the array in its original form, and we will not be mutating. We will not be mutating it, okay? Because we need to run the check, because the values in their current index matters, okay? Run a check and determine, based on the constraints, and determine whether the values and their respective indices make up a good triplet. Okay. In our array, we will not be being passed any alphabetical characters, special characters, nested arrays, or nested objects. So it will be fairly simple. We don't have to do any manipulation in that sort. And what are we returning? So if you come across a good triplet, count it and return the total count. Okay, perfect. So let's start by creating a variable. Create a variable to hold your total count, which will be let count, which is a number, equal to 0. And it's important that it should be a number, because our function here is expecting of us to return a number. Cool. And now we need to do 3 checks. And since we're going to be doing 3 checks and we need to iterate over the array 3 different times, we're going to be I'm going to be using a brute force method. It's going to look a little bit ugly. It's going to look there's going to be a lot happening, but essentially it will get the job done. So if we're going to be using a brute force method, we're going to be iterate over the entire array. Okay, so this outer loop will be an iterator over the entire array. Number equal to 0. I is less than array.length, and then I++. Okay. And I'm not going to do anything in this iterator because we're not running a check yet. Then I need to iterate over the loop and find the first comparison. Okay. And if we're doing that, we're going to be using a secondary for loop. So it's going to be j, which is also a number, equal to I plus 1, because we never want to start before I. Okay. It's also going to go for the entire duration of the array, and then j++. And then we're going to need to do another iterator for the second comparison. So I'm just going to copy this, paste this here, and we're going to do the second comparison. Perfect. And in our third loop, this is where we're going to be doing most of our work. Okay? So we're going to say let k, which is also a number, equal to j plus 1. Okay? So because we always want to start one farther ahead of our second, like our first comparison. And it's going to be k is less than also array.length, because we don't want to go any farther than the full length. And then k plus plus. Okay? Now you can end up like optimizing this so that, because you know that I should stop too short of the end of the loop, and j is going to start one short of the end of the loop. But for the time being, and until we can get a working solution, I'm just going to run it this way. So now that we are in our third loop, now that we can run our comparisons between I, j, and k, we need to just check our condition here, right? And so what we will do is this. If we will just be using, now we need to satisfy these 3 bullet points here and then add to our count. Okay? So and it tells us exactly what we need to put into our conditional, which is kind of helpful. But since we are doing the absolute value, we are going to start off with saying math.abs. All right? It's going to be array of I minus array of j. Okay? Is less than or equal to A. And I'm just going to copy this. Control Z, and paste this here. And it's going to be array of J minus array of K is less than or equal to B. And then one last time, this is going to be C, and then this is going to be I and K. Okay? If all of these three conditions are true, right? If all of these three conditions are true, then what are we going to do? Count plus equals to 1. Okay? Kind of ugly, right? Like it's a triple for loop. So what you're seeing is an O of n at least solution, right? Like, so the time complexity is n cubed, sorry, O of n cubed selection, time complexity. And then once we've finished operating over our loops or doing our loops, what we will do is return the total count, right? And we can return count, which should, for us, take care of this return here in the function. And you can see it's no longer underlined with a squiggly line. So let's try running this. Let's see what happens. It's going to be a little bit slow because of the triple for loop, but it satisfies our condition, right? And we take a look at this next one here. We have A0, B0, C is 1, and an output of 0 and 0, right? Now let me try, if I did this here, minus 2, right, and minus 1, will this still work? Because then it won't have to run all the way through. Right? Perfect. I don't know if I didn't really compare my results, my runtimes. I didn't really see if it cut down anything on the length of running the program, but it's just a little bit more efficient. And it's good to know. It's good to understand, like, why, if an interviewer asked you, why would you want to stop at 2 short and 1 short, depending on which loop you are on, right? Okay, so if you like this video, please like the video. If you learned something, please leave a comment on the video and tell me what you learned. I would really appreciate that. If you think that there is anything that I can improve on in terms of the videos itself, also let me know about that. If you found the solution helpful, share it with your friends, subscribe to the channel, do all that lovely stuff. It would really mean a lot to me. And once again, my name is Jamil. Thank you so much for joining me today on this LeetCode, and I'll see you next video.